Chapter 6-7, Polygons in the Coordinate Plane. Let's go on to this one. What is the most precise classification of the quadrilateral formed by connecting in order the midpoints of each of the figures? Okay, so if I want to find the midpoint, I want to find the midpoint and then connect my midpoints. So if I find the midpoint of from here to here, then what I want to do is my midpoint formula is x1 plus x2 over 2, y1 plus y2 over 2. My x1 here is negative 3 plus my x2 here, which is 3 over 2. And now I'm going to do my y1. My y1 here is 0 plus my y1 here is 2 over 2. So I've got 0 over, this one here is going to be 2 over 2, which is 1. So at x is 0, y is 1, there's my midpoint. Alright, let's find our next midpoint from here to here. So my x1 here is negative 5 plus my x1 here is negative 3 over 2. My y1 here is negative 4 plus my y1 here, which is 0 over 2. So here I've got negative 5 and negative 3 is negative 8, so it's negative 4. Negative 8 divided by 2. Negative 4 divided by 2 is negative 2. Negative 4, negative 2. Here's my midpoint here. Next one is right here. So I'm going to do my x1 is negative 5 plus my x1, which is 1, over x2, sorry, and then my y is negative 4 and my y here is negative 2 over 2. So here I've got negative 5 plus 1 is negative 4, negative 4 over 2 is negative 2, negative 4 and negative 2 is negative 6 over 2 is negative 3. I've got negative 2, negative 3. Here's my midpoint here, and then finally I want the midpoint of here, so let's move this up a little bit so I have some room. Alright, so my x1 here is negative 3 plus my x1 here, which is 3 over 2. Oops, I'm sorry, I found that one already. Wrong one. This one here. Okay, I was looking at the wrong one. My x1 is 1 plus 1, 2, 3 over 2. My y1 is 2 plus negative 2 over 2. So I've got 1 plus 3 is 4 over 2. That's 2. And 2 minus 2 is 0. So at x is 2, y is 0. My form right here is what I have. What I could do to figure out what this is, right now it looks like a rectangle, but if I know that these are 90-degree angles, then I can say that they're quadrilateral. So let's look at the slope. So here I'm going up 1, 2, 3, and over 1, 2, 3, 4. Now, let's see what my slope is here. I'm going down 1, and over 1, 2. So I can say that these are rhombuses. These two lines are not perpendicular. Let's get rid of those then. The only thing we know is that this is the figure that we've formed. Okay, here's the most important formulas ever. And the good thing is that you are given these extra steps. You want to make sure that you understand this. This is going to tell you when to use it. Next one, to classify a triangle. Is ABC a scalene, which means none of the sides are equal, an isosceles, which means two sides are equal, or an equilateral, which means all sides? Okay, so what we need to do is we need to decide, is it scalene, isosceles, or equilateral? In order to do that, we need the distance formula. So the first going to start from A, and the point at A is x is 0, y is 1, and the point at C is x is 7, y is 0. So using the distance formula for AC, we're going to get, let's do our x1, which is 0, minus our x2, which is 7 squared, plus our y1, which is 1, minus our y2, which is 0 squared. We end up with 7 squared, which is 49, plus 1 squared, which is 1. So we've got the square root of 50. All right, the next distance, we'll do this one in blue. Okay, so in blue, we've got the distance of, we're going to go from A to B, and our point at B is x is 4 and y is 4. So from A to B, we've got our x1 again is 0, minus our x2, which is 4, plus our y1, which is 1, minus our y2, which is 4 squared. So we end up with negative 4 squared is 16, plus 1 minus 4 is negative 3, which is squared is 9. We get the square root of 25. Okay, and then finally, we'll do it in black. Finally, we're going to do the distance from B to C. All right, the good thing is we already have our coordinates for that. So we will start with our x1, which is 4, minus our x2, which is 7 squared, plus our y1, which is 4, minus our y2, which is 0 squared, and we end up with 4 minus 7 is 3, 3 squared is 9, plus 4 squared is 16. We got the square root of 25. So we've got that AB is congruent to BC, therefore we have an isosceles triangle. Okay, this next one is a got it. This is where you get to do it, so you go ahead and pause, and I'm going to put the answer on there. Okay, problem number 2. Okay, so it says that the parallelogram ABCD is a rhombus. Explain why. And one of the things, if you remember, a rhombus, its diagonals are perpendicular, so all we have to do is do the slope. The slope formula is the difference in our y's over the difference of our x's. So we'll find the slope first of AC. And the slope of AC, so we'll do our y2, which is 0 minus 5. And so we've got negative 2 minus 4, which our x is. 0 minus 5 is negative 5, and negative 2 and negative 4 is negative 6. So we have a slope of 5, 6. Now we need to do our slope. We did AC, let's do BD. So again, our y2, BD, we're going to have y1 minus 4 over our x's, which is going to be 2 minus 0. So we end up with negative 3 over 2. And so your slope is negative 3 over 2. If you notice, these are not reciprocals of each other, or opposite reciprocals. So this is not a rhombus. So another way you can check is multiply your slopes together. And when you multiply them, you should get negative 1. And we get negative 15 over 12. Okay, the next one is a got it. I'm going to put all the answers on for you. And so go ahead and pause and let's see if you can get it right. Okay, so A is a rectangle because if you found out the slopes of the intersecting sides, what you would find out is they are all opposite reciprocals of each other. Therefore, they're all perpendicular. On B, it is a square, and in order to find out if it's a square, you had to find out all the distances of all the sides, and you'll find out that they're all equal. And then on C, in problem number 1, you found out that it is a right triangle, because if you find the slope of AB and BC, you'll find out that they're opposite reciprocals of each other. Okay, problem number 3. Okay, so in this one, it says, what is the most precise classification of the quadrilateral form by connecting the midpoints of the sides? So I think the best thing to do first is find out all of our coordinates. So our coordinates at E is at x is 0 and y is 1, 2, 3, negative 4. At K, we've got x is 1, 2, 3, negative 4, y is 0. And then at Y, we've got x is 0, and our y value is 4. And at X, we've got x is 1, 2, 3, 4, 5, 6, 7, 8. And our y value is 0. So in order to find the midpoint, you need to use midpoint formula. And the midpoint formula, if you recall, is x1 plus x2 over 2, y1 plus y2 over 2. So we'll start with KE and find the midpoint of KE. So for our x's, we've got negative 4 plus 0 over 2. And for our y's, we've got 0 minus 4 over 2. Therefore, our coordinates here for our midpoint is going to be negative 4 over 2, which is negative 2, and negative 4 over 2, which is negative 2. So our midpoint is going to be at negative 2, right here. All right, the next one we're going to go for, let's see, we did KE, let's go ET. And ET, let's go our x's first, 0 plus 8 over 2. And then we've got negative 4 plus 0 over 2. Therefore, our coordinates are 8 over 2 is 4, and negative 4 over 2 is negative 2. So we've got 4 and negative 2. Here's our next coordinate. And next one, we will do TI. So do our midpoint. So for TI, we've got 8 plus 0 over 2. And then we've got 0 plus 4 over 2. Therefore, our midpoint coordinate is 8 divided by 2, which is 4, and 4 divided by 2, which is 2. So we've got x is 4 and y is 2. And then finally, let's pick another color. Let's go green. And with green, we're going to do KY. And so with KY, we've got negative 4 plus 0 over 2. And then we've got 0 plus 4 over 2. Therefore, negative 4 over 2 is negative 2. And 4 over 2 is 2. So we've got negative 2, 2. And if we connect all of these points, this is going to be our parallelogram on the inside. So let's go to the next page. Okay, so now on this one, all we have to do is find the distances. We don't have to use a distance formula, just count the triangle, or count the squares. So the distance of AB is going to be 1, 2, 3, 4, 5, 6. The distance of DC is going to be 6. The distance of AD is going to be 4. And the distance of BC is 4. Therefore, we have a rectangle. Okay, now this is just to check to see if you know what you're doing. So what we're going to do here is I'm just going to give you the answers, and you can check to see if you've got the right answers. So go ahead and pause. Okay, for number one is an isosceles, so you obviously found that 2 of the sides are congruent. And for number 2, it wants to know if it's a rectangle. It is not, because the diagonals are not congruent, and the actual distance of the diagonals is square root of 29 and 5. And the last one, number 3. Okay, number 3, you're going to use the distance formula and then compare the lengths. And for number 4, you should notice that it's not a parallelogram, that the sides are not parallel. Okay, and the homework is right here. Good luck. I know you'll be successful.